Alright, what's up guys? In this video we're going to pick up with some calculus here. It's going to be another integration practice video. So I'm going to evaluate the integral x squared times sine of 3x dx. So as you can see here, we have a product of two different functions. So we're going to apply integration by parts here. So remember the formula for that, it's the integral of u dv. It's equal to uv minus the integral of v du. So we need to pick a u and a dv. So in this particular case, I will let u equal x squared and dv will be everything else. So dv will be sine of 3x dx. Also notice that when we look at this integral here, we can tell that we're going to have to apply integration by parts twice, because when we apply it once, it's going to drop this power of x down to 1 and we have to do it again. So I've mentioned in previous videos how you can identify when you'll need to apply integration by parts multiple times. There are cases where you can use tabular integration, but tabular integration does not work all the time. So keep in mind that sometimes you may have to do it the long way, because tabular integration doesn't always work. So keep that in mind. So let's go ahead and take the derivative. So if we take the derivative, we'll get 2x dx. And then to get v, we integrate dv. So that's the antiderivative of sine of 3x dx. And hopefully you have that one memorized. That's just negative 1/3 cosine of 3x. Okay, so when we go and apply integration by parts for the first time, I'm going to write this side as negative 1/3 x squared cosine of 3x. And then it'll be minus v du, so that would be minus, and then I'll have integral negative 1/3 cosine of 3x times 2x. So two negatives make a positive. I'll end up with a positive 2/3 on the inside of the integral, which is just a constant, so I can factor it out front. And then I'll just have the integral of x times cosine of 3x dx, which would be on the inside here. And as you can see, as I mentioned to you when we started the problem, we're going to have to apply integration by parts a second time here to finish off the problem. Now, in situations where you have to apply integration by parts multiple times, first of all, you want to make sure you're being neat for any math problem, not just a calculus problem. But you definitely want to make sure you're being very neat when you have to do integration by parts multiple times, because you're going to have to go back and connect your second by parts to the left-hand side of your first by parts. So if you've got stuff all over the paper, you're going to get lost pretty quickly. So let's not deviate too much from the substitutions that we had at the beginning. Let's kind of keep them the same and not change them for the second by parts. So for the second by parts, I let u equal x. So I need du, and then I need v again. So du, that's just dx. Now people say, well, isn't the derivative of x1? Yeah, but you do have to multiply by dx. So 1 times dx is just dx. So you can just write dx instead of writing 1 dx. And then for this part, we'll have the antiderivative of cosine of 3x dx. And again, hopefully you can do that one in your head. That's just 1/3 sine of 3x. So when we do the second by parts, and I'm not going to connect everything at one time. I'm going to just do my second by parts, finish that out, and then I'll go back and connect it to the left-hand side of my first by parts. That's the way I prefer to do it, so that it doesn't get a bit confusing. So we'll end up with 1/3 x sine of 3x. Then this will be minus v du. I can pull out a 1/3. And then I'll be left integrating sine of 3x dx. And we've already integrated that, but I know I have a negative 1/3 on the outside. So I know I'll need to multiply that by whatever I get when I integrate sine of 3x dx. And we already know what we're going to get when we integrate that. So that's going to be negative 1/3 times, and we know we're going to get negative 1/3 cosine of 2x. I'm sorry, not 2x, 3x, excuse me. And that'll be 1/9 cosine of 3x when we do that. Again, I'm saving the integration constant plus c until we get to the end. Okay, there's no need to tackle them on right now. So now we need to go ahead and write out what we get for our second by parts after we've done everything. So for the second by parts, we end up with 1/3 x sine of 3x. And then it's just going to end up being plus 1/9 cosine of 3x. So we can tackle on plus c now. So that's what we get with the second by parts. Now what we have to do is we have to take all of this and connect it to the left-hand side of the first by parts. So as you can see, it gets pretty involved, and that's why you need to make sure you're being very neat. So we'll go back to the left-hand side of our first by parts, and if you remember, what we had was negative 1/3 x squared cosine of 3x, and then it was plus 2/3. And then when we did our second by parts, we have all this here, and it's going to be 1/3 x sine of 3x plus 1/9 cosine of 3x, and then plus c. And we can go ahead and distribute in the 2/3 right here and finish the problem out. So your final answer for this integral is going to be long, but just because the answer is long or it looks long doesn't mean it's not correct. Oftentimes in math, especially in calculus, your answer will be some funny looking number, or for indefinite integral, sometimes it can be some long answer, but that doesn't mean that it's incorrect. That's just life when it comes to math. So our final answer for this integral is just going to be negative 1/3 x squared cosine of 3x. And if we distribute in the 2/3, looks like we'll end up with a plus 2/9 x sine of 3x. And then we'll have 2/3 times 1/9. That'll be 2/27. Then we'll have cosine of 3x, and then just tackle on the plus c. And that is the answer. So let me circle that for you. So as you can see, this one did require a little bit of work, but a bit of a long problem, but not necessarily a hard problem. All right, so that's how you evaluate that integral. So let me know if you have any questions about how I got my answer. I'll be more than happy to explain it further. All right, guys, I'll see y'all next time. Y'all take care.